All right, everyone, this is our nuts and bolts activity, and we're going to go over to how to distinguish between atoms, molecules, elements and compounds, and a few other terms, okay? So the first two terms you want to distinguish between are atoms and molecules. And with nuts and bolts, these are the symbols that we're going to use just in case you're not too familiar with these, all right? So for a nut, kind of look like a hexagon, all right, kind of have a hexagon shape. A circle in the center. Not my best picture there. That's kind of what it looks like. Got a hexagon, a nut, a bolt is going to look like kind of like a T. You want to get real fancy, you can put the threads of the bolt on there if you want. And then a washer. So nuts, bolts, and washers. And so a washer is basically looks like a donut. Okay. So nuts, bolts, and washers. And you'll see some real-life examples of those here in a second. Okay? So we're going to go through some different ways we can understand atoms and molecules and all that using nuts, bolts, and washers. We can draw some pictures. And the way this flow chart works is everything's going to connect sort of going down. So at first we want to distinguish between, on a small scale, an atom or a molecule. What's the difference between those? All right? So if you see something that is alone, then we're going to consider it an atom. So let's say if we had a washer. I tend to draw a lot of washers because they're easier to draw. Let's say if we had a washer by itself, then that would be considered an atom. A model for an atom. A bolt by itself. All right, something like that. Where molecules, we're going to say that they are connected. All right. In the past, I've used some phrases like maybe, so, we say A, and I use the word alone because they both start with A, alone and atom. Sometimes I would say married for molecule, but sometimes you can have two of the same atoms connected, and then people get it all sorts of bent out of shape sometimes. So let's say that we had two washers connected. That would be a molecule. All right. If you had a bolt and a washer, for instance, okay, bolt and a washer connected, that's considered a molecule as well. You could have three washers connected. We could even make this three if we wanted to, just as long as you have two or more things connected. And they can be the same or they can be different. All right? So the first thing that we'll ask you to do is distinguish between an atom or a molecule when you see sort of a picture of something. Okay? And you're going to have a petri dish of some different things that, and you'll have to distinguish, is what you're looking considered an atom, a molecule, or possibly do you see both of those in there? All right? Now moving down here, atoms are the smallest unit of an element. And an element says it consists of only one type of atom. So if you had, let's say we had a washer again, this would be considered an element. All right, because it's only one type of thing. So let's say you had a petri dish, and let's say you had this right here. So that would be considered an element. A picture of an element yielding one type of compound. All right. You could also have, all right, so that's one way we could express what an element could look like. You could also have an element that was made of molecules, so you can see how molecules are connected. So let's say that you have two of the same atom joined together. You could also have that. So let's say that you would have, let's say we had two bolts connected to each other. So on a small scale, I would call this a molecule. All right. If I had a lot of them on a big scale, I would say this would be what an element looks like. So I'm only ever going to ask you to distinguish, is what you're looking at an atom or a molecule or possibly both of those? And then are you looking at an element, a compound, or possibly both of those? Okay. Now, if you had a bunch of these bolts and washers like this, on a big scale, you would call this a compound. Because as you look in here, let's say you had a bolt and a washer, that would be considered a compound. All right. Also, another thing that you could consider a compound, let's say we had a washer and a nut. So that would be considered a compound as well on the big scale. All right, move that up a little bit. So that's what these can look like on on kind of a big scale. Now, the next kind of question we can ask you is what you're looking at homogeneous or heterogeneous? And we remember from our roots, maybe in our prefixes, homo means same, and then hetero means different. Okay, so I could ask you if you had a picture of maybe a couple bolts in here, and I would ask you, is this homogeneous or heterogeneous? And this would be homogeneous because everything is the same in here. Even if I added a third bolt in there, then it would be homogeneous. But if I had a picture of that, or maybe a petri dish that had a bolt and even like two bolts, but the third one would maybe be a washer, this would be heterogeneous. So everything that's in there are not the same. Okay? Now, let's say that we had a picture like this. A bolt and a washer and a bolt and a washer. Okay? So bolt and a washer and then another bolt and a washer. Would this be heterogeneous or homogeneous? What do you think? Is this the same as this? They are. So to make this heterogeneous, I would actually have to add another washer, okay, or something else in there. So this, whether you consider this molecule is different than this one, or this compound is different than that compound. So two different compounds there. All right, and so let's see here. And then finally you have a mixture. So a mixture is considered, and this kind of goes back to our when we discussed suspended colloids and dissolved particles. Mixtures are a combination of different things that have their own identity. So if something is heterogeneous, it's going to be a mixture. So in this picture, I would actually say I have a mixture of different elements. In this picture here, in this picture here, I would say I have a mixture of two different compounds. I could also have, so you could actually have a mixture three different ways. You could have a mixture of different elements, like we said. Okay, and right there, this would be an example. You could have a mixture of different compounds. And you could have a mixture of maybe an element and a compound. So those are your possibilities. So when you're asked to tell me, if you decide you have a mixture, you want to be specific about what type of mixture you have. Okay? Because you can have three different kinds, you want to be specific about it. Okay? So what we can do is we're going to have some space where we kind of go through some different examples of what we see. So we're going to turn to the next page, and let's see. All right. So at the top here, there are 4 columns. The formula part we're going to do a little bit later. So don't cross it out, but we're really only going to work on the first 3 columns. All right? So what I'm going to do is I'm going to have some different, a Petri dish I'm going to have up here for us. And I'll put some different, I have a nice picture here of, get this on the screen. And we're going to go through a couple examples. Okay, so let's see here. So this would be my first example, and so let's see. So from the picture, I've got, this is going to be a bolt and a washer, and since they're in contact, they're connected. And then a bolt and a washer, and they're connected. So in this first example, since they're connected, would these be atoms, molecules, or possibly both of them? All right. And so since they're connected, we're going to say that these are molecules. Okay? So for this picture, we're going to say molecules, or for that first column. All right. Now, the next question says, is this what we have in here heterogeneous or homogeneous? So is this molecule the same as this one? Yes, they are. Okay. So we're going to say it's homogeneous, and we're going to go ahead and write out the whole word, homogeneous. And then, do we have an element, a compound, or a mixture? Now, you'll notice that I actually read that different than how it's written up here. So I don't ask, is it a mixture first? I think that's kind of complicated. I want to say, is this an element or compound or mixture? And take it one step at a time. So since these are the same, we already recognize these are the same. Let's just look at one of them by itself, cover up the other one. So if it's an element, then it'd be 2 of the same things connected. And that's not what we see. We have 2 different things connected. So this is going to be a compound. And since this other one's the same, we're just going to write that it's a compound. All right. Now let's do another example, and I'm going to change what we have here. So, and then some of the materials that we have are different sizes, kind of whatever we could find in the hardware store. Okay, so we have a washer and we have a bolt, and they are not connected. So do we think we have these atoms, molecules, or both atoms and molecules? Think about that for a second. So the word that we used for atoms was alone. This washer is alone. This bolt is alone. Okay? So what we have are atoms in this case. All right. And then for, are these atoms the same atoms? No, they're different. So they're heterogeneous. And we have, and so these are atoms, right? So with atoms, we want to ask, if they're atoms, they're not connected, right? So they cannot be a compound. So if they cannot be a compound, that means that, since they're alone, they're elements. So this is an element, and then this would represent an element. Are they the same element? No. So the best answer is to write that they are a mixture of elements. And what you're going to notice is that anytime it's heterogeneous, it's automatically going to be a mixture. All right? So if it's heterogeneous, you must have different parts, different things. If you have different things, then it's going to be a mixture. And our example from last unit of mixtures is a salad or something like that. So a salad would be different things. They all retain their own identity. This washer is different than this bolt. Okay? All right. So those are some different examples that we have. And what you're going to do when you go out to lab, you're going to go through and look at some different pictures like this, and you're going to try to answer the first 3 columns as best you can. My suggestion: do this in pencil. It's a little bit tricky initially. All right, and we're going to kind of practice with this. All right.